Okay, students, this is Dr. Nelson again. Today we're going to be talking about minerals in our lectures videos today. And this corresponds with Chapter 3 in your text, and give you guys some additional reading as well online, and some also parts of the mineral resources section in your text as well. Okay, so we're going to go through this hopefully and show you a little bit about minerals and talk a bit about what they are and what they aren't, and then we'll kind of go through from there. Okay, so we're going to start off. I love flowcharts. And flowcharts are a way to help us to kind of put different ideas together. And so I'm doing this to give you the different ideas of what a mineral actually is. So a mineral itself has many different characteristics or characteristics to it. And so a mineral is a solid that is also coherent. Coherent meaning stuck together or put together in one mass. Okay, and then it's also natural, so it's naturally occurring. Okay, so it's not something that men or man-made can make. So it's a naturally occurring substance. It is made of elements, so elements within the periodic table like silicon and iron, or silicon and oxygen, things like that. Okay, it has a definite chemical composition. Okay, so for example, quartz. I have a thing of quartz here, right here in front of me. And this quartz is made up of silicon and oxygen. One silicon, two oxygen is a basic quartz crystal. Okay, and so that would be your definite chemical composition for quartz. Now, other minerals have different chemical compositions as well, and you can do that when we look at our discussion page when you identify and look at different minerals. Now, also, a mineral must be crystalline and inorganic. Okay, so it has to come from an inorganic substance. So, for example, things that are like our teeth, which are sometimes some people call mineralized, have all these same characteristics. It's a solid, it's coherent, it's naturally occurring. It has, to a point, a definite chemical composition. It has crystalline structures to it, but it is organic in nature. So we call it a mineraloid, which means it's mineral-like. Okay, but it's not technically a mineral. And so, but minerals are usually are in rocks. So rocks are made up, or minerals are combined to make rocks. So, for example, this is a rock that you probably see a lot in this area, and it's a granite. It has lots of big crystals in it, so little different crystals throughout it. Okay, but it's made up of lots of different minerals. For example, this mineral right here in the middle, okay, or these guys here, these big ones. Are made up of feldspar. So this is a mineral of feldspar right here. Okay, you can see some of the crystalline structure of that feldspar. But also some of the dark material in this rock, sorry, get it on there, is hornblende, which is another example of it right here. Okay, get my video here. Is an example of hornblende. Then we have quartz, which I just showed you just a second ago. And then we have also some micas in this. Okay, so this granite is composed of lots of different minerals. Okay, and so that's what a rock is. A rock is composed of that. And they usually can be different types of them. Okay, these could be, I'm going to go through, there's different types of rocks. Igneous rocks, sedimentary rocks, and metamorphic rocks. We'll get back to those. Now these minerals or elements are often used in different products. Okay, and these products, or the materials that we get them from, are what we call mineral resources, and that could be mined economically. We call them mineral reserves. Okay, so we can find tons and tons of quartz inside of this granite here, but it's not very economically for us to extract that granite. I'd much rather go down to a beach or where you have some quartz sand and get it in abundance, and then be able to mine it from there. Then I have to mine it and try to extract it and separate it from the granite the way I just showed you. Right? So this would that beach sand would be an example of a mineral reserve because it could be mined economically. Whereas that granite, if I'm just getting it for just the quartz, could not be mined economically in that aspect. So we can mine it economically for other things like granite countertops or for ballast on the railroad track outside here, but for just to get quartz out of it, it's not economically feasible. Okay, so those are some examples. We'll talk about these ideas a little bit more. This is just to introduce you to the topic here. Okay, so this is just kind of a summary slide here. Just give you kind of some of the same ideas. Here's that granite. You get quartz, hornblende, feldspars. You can get micas, lots of other minerals in here as well, but it's an aggregate. A rock is a naturally occurring aggregate of minerals and or mineraloids. Okay, so mineraloids, remember, are things that are close to being minerals, but they don't have all those distinguished characteristics. Okay, and we'll give you some examples of those in just a second. So here's some examples of some minerals. Okay, so you have quartz here. That's the one I just showed you here. Okay, here's some example of quartz. It has silicon and oxygen in it. Okay, so 2 oxygens for every silicon atom. And it has a definite chemical structure to it. They actually bond in certain directions in certain ways. Now here's another example of one, hematite. Hematite has lots of iron and oxygen in it. It's something that we mine a lot for iron. And so it has a chemical structure to it as well, and distinct chemical composition. Diamond is a great example. It's pure carbon, and that pure carbon here has a definite chemical composition and structure to it to form diamond. If we didn't have that same chemical structure to it, we could actually get something else called graphite, which is something that we use in pencil lead. Okay, or here's the last one here is halite, which for you is sodium. Sodium is actually a very reactive metal. Chloride is a very dangerous gas. You put the two together and you actually get table salt, right, that you guys eat every single day. And so these are just examples of how you can get different chemical formulas, structures of different minerals. Okay, well, how do these minerals form? They form in a lot of different ways, but usually those elements are in some kind of a melt. Okay, so we're talking about lava or magma or something like that. Or it could be from something else, but we'll start with that. It would be from a melt, and as it slowly cools off, the different elements within that melt crystallize together to get the different minerals inside of that granite, right? Okay, and so, or you can get minerals precipitated from a liquid. Okay, let's say, for example, the ocean. The ocean has lots of salts in it. And if that water evaporates away, what is left behind is the halite or gypsum or other types of salts that actually are left behind. You can sometimes get this when you boil water. You have lots of salts in it, and you boil all the water away. You might have this white residue around the pan, and that's the salts that's left over after the water's evaporated away. Right? So that's your precipitation from that liquid solution. You can have diffusion in solids. So if you have a solid, if you put it under some heat and some pressure, put some fluids in there with it, you can actually have the materials themselves start to crystallize from off that solid. Okay, biomineralization. That's an example of like your teeth, an example of shells and bones. Precipitation from a gas can happen as well. You get nuclides from gases, but for example, from the sulfur or something like that coming out of a vent, you can start getting precipitation there. So those are all some examples of how we get minerals to form. So, which one of these is an example of a mineral? Okay, so remember what your definition of a mineral is, and let's try to go through them. Let's start off with the bones. Is this an example of a mineral? And you say no on this one. Part of the reason this one is we call these mineraloids. They are naturally occurring. A lot of bones have chemical structures to them and chemical compositions, specific chemical compositions to them. However, they are being formed by our organic material. Okay, so they're an organism at some point. And so we would consider these mineraloids, just like the teeth here for this one. This one is also a mineraloid, right? So that goes the same for the shell. What happens with the organism here is they extract some materials from their environment. If it was a gastropod or a snail that lived in the ocean, they might get some of the elements from the water itself to precipitate their shell, or maybe some from some of the materials that they are eating. So a lot of snails will actually graze on rocks and things like that to get the minerals out of those materials to build their shells. Now, how about water? Water has a chemical composition. It's H2O, right? Hydrogen and 2 oxygen. Sorry, 2 hydrogen and 1 oxygen. I said that wrong. Okay, but it is not solid, right? So that means it's not a mineral. Coal does have a chemical composition. It's chemical structure. It's solid. It's coherent. But there's a problem with this. Solid coal is actually made from compressed plants. And so this has come from, once again, an organic background. So this would be what we call a mineraloid again. Now ice is actually the mineral in this case. It has a definite chemical composition, a definite chemical structure. It's solid, it's coherent, it's inorganic. So it meets all the requirements of a mineral. So ice can be considered a mineral. Okay, so that's just one example. Let me give you some other examples. Here's a synthetic diamond. Well, in this case, what we call cubic zirconium, right? No, this is not a mineral. And the reason is this is actually made by man, right? So it's not natural material. Okay, obsidian, that's glass. Glass is not a mineral, and the reason is it doesn't have an actual chemical structure to it. Glass is what basically happens to it is the material itself actually cools off so fast it can't get into their actual bonds in the way that they should. This is part of the reason why when you break it, it will break off these sharp edges and what we call fractures to be able to use for arrowheads and things like that. An emerald is actually a mineral. It's a gem, but all a gem is the good quality mineral that we use for jewelry and things of that nature, right? And so amethyst is also a mineral. It has the same classification there. Amber is actually petrified tree sap, therefore that would be organic in nature, so not a mineral. And petrified wood is a troublesome one. And the reason is because it does have an organic background, but what happens here is all the organic material, as water flows through it in the ground after the tree has died, is being replaced, the organic material is being replaced by inorganic material. So some people can argue that it's a mineraloid, and some people can argue that it's actually is a mineral. It depends on what you're talking about. But I just wanted to give you some examples of these to be able to help you understand what is a mineral and what is not. Well, what are minerals used for? Well, they're used for a lot of different things. All of these minerals can be found here in North Carolina. Beryl, which is actually green beryl, is what we call emeralds. Then you have a sapphire here, which is also a beryl, but it's a blue type, right? So we can use these for increasing the electrical and thermal properties of metal. We use it for gemstones as well. Garnet, we can use these as for gemstones, but often we use it for abrasives or filtration to actually filtrate water. Spodumene. Spodumene is a great source for our lithium batteries that we use all the time in our phones and things like that. We put it also into paint, into medicine, photography, a lot of different things. Pyrophyllite. We actually use this in soap, in bleaching powders, electrical insulators to be able to increase the electrical insulation of a material. Feldspar. We use this for tiles, cement, dinnerware, TV screens, a lot of different things to make it a little bit stronger. Mica has a great insulating factor to it, so we use it often in things to absorb heat. So for toasters, glasses, vacuum tubes, things like that. Gold, we use it all the time, and you guys probably have it in your phone. We have lots of gold in our phone because it's a very good electrical conductor, and so we use it for wiring in electronics. Also use it for currency and jewelry, as you guys know. Quartz, the quartz that we just showed you just a minute ago, which I can't seem to find off on my desk right now. There it is. Okay, that quartz is also in our phone. It's used in our screen for sealants, electrical supplies. We sometimes will see quartz or silica, pure silica, in little packets to take out moisture, like let's say maybe your beef jerky or your purse when you first buy it, because quartz has this property of absorbing moisture. So all things that we can use minerals for, and we have to mine all of this to be able to get those materials. So everything we have around us, if it wasn't grown, okay, if it wasn't grown on this planet, it was mined. And so if you think about it, everything we own has come from the earth somewhere. Okay, so for this phone, we have silica in it, we have metal in it that we had to mine, we have this plastic for the covering here is from petroleum, we have the gold for the wiring, we have silver for the wiring, we have, let's see here, rare earth elements to get the different displays so many different things that we can use for in our everyday lives. Okay, so think about it. Minerals, we use it every day.